So these are trig identities. And basically, what is a trig identity? They're equations that involve trig functions, and basically you set them up so that the left side and the right side are equal to each other. Okay? So back in chapter 4, we learned about sine, cosine, tangent, and so on. And then, so we learned about sine of theta, and then we learned about cosecant of theta, right? And how were those two related to each other? It's the reciprocal, right? We said that cosecant of theta is 1 over sine of theta. Do you guys remember? Right? So if cosecant is the reciprocal of the sine, if it's 1 over sine, then sine is 1 over cosecant. All right? So these are called reciprocal identities. And here we've just listed them again. So this is nothing new, really. It's all stuff that you've known. So look, sine of theta is 1 over cosecant. Cosecant is 1 over sine. All right? And then the next pair was cosine and secant.
It just switches.
Yeah. So each, like cosine and secant, each one is 1 over the other. Cosine is 1 over secant. Secant is 1 over cosine. Tangent and cotangent, 1 over each other. All right? So we call those reciprocal identities. All right? Now, we also said, remember, we also said that tangent is sine over cosine. Do you remember that?
No. Because it's y over.
Because it's y over x, exactly. So remember on the unit circle, if that was sine and this was cosine, right? What was tangent? Opposite over adjacent, so that's sine over cosine. Cotangent is cosine over sine. So these are your quotient identities. Okay? So those are, now we have like 2 sets of identities. In this entire chapter, we're going to be introduced to several of these. And the purpose of the objective of this chapter is, you have like a trig problem. You look at it, you have to identify which identity you can use for that one. Apply the identity, get your answer. Okay? All right, so take a look at this. In other words, if you're given sine of theta, then cosecant of theta is the reciprocal, right? So for example, if somebody tells you, hey, sine of theta is 2 over 3, then what would the cosecant equal to? 3 over 2. Okay? All right, so let's go through these two then. If cosine of theta is 3 over 4, what's secant of it?
4 over 3.
4 over 3. And then, in the next one, if secant of x is 5 over 4, and tangent of x is 3 over 4, find sine of x. So this one is a little bit more complicated, right? But, look, secant of x, that is the reciprocal of what? Cosine. So from that, I find cosine of x is what? 4 over 5. Okay? And tangent of x is 3 over 4. Okay? So, if you have cosine and you have tangent and you need sine, is there an identity here that relates sine and cosine and tangent?
Yeah.
Which one of these?
Tangent theta equals.
This one. Right? So, tangent theta right? Now, which one is it that I want to find? cosine, sine of x, right? Huh? Okay, Sam says to multiply both sides by cosine. Let's do that. Okay, that's awesome because now we know that sine of x is equal to cosine times tangent. Well, do we have the cosine of x given to us? It's 4 over 5. Do we have the tangent of x given to us? 3 over 4. So what's sine of x? Yep.
Also, can't you just know that if cosine of x is 4 over 5 and tangent is 3 over 4?
Right, but like a lot of, right. Sometimes like, this is like the most basic case.
Yeah.
They get a little bit more involved. But yeah, if you can just figure it out, give the answer. Because, do you understand how we did 4 over 5 times 3 over 4? Yeah. This and this cancel. Okay. All right, so take a look at this for a minute. You see the triangle inside here? Right? What kind of triangle is that? This triangle here. Is this a right triangle, acute, or obtuse? Right triangle. And if it's a right triangle, can we use the Pythagorean theorem?
Yes.
Yeah.
Right? Okay, so now, if this is x, and this is y, and that's 1, what does the Pythagorean theorem say?
It says that
Y squared plus x squared is equal to 1 squared, all right? So y squared plus x squared is equal to 1 squared. Now, we've also said that when we're dealing with trig, the vertical side is always sine, the horizontal side is always cosine. So instead of y, I can put sine, right? So sine of theta squared plus cosine of theta squared is equal to 1. Okay, another way to write sine of theta squared is sine squared theta plus cosine squared theta is equal to 1. Okay? This, right, but then 1 squared is what? 1. Yeah, but we just simplify it. And then this right here, believe it or not, is a world famous trig identity. World famous. Sine squared plus cosine squared equals 1. Sine squared plus cosine squared equals 1. All right? Huh? Same thing as what? Yeah, but this this way of writing it, where the 2 is after the sine, it's more conventional. That's the famous way to write it. This is, okay, so where did we come up with this? We started using the Pythagorean theorem, right? That's why this is called the Pythagorean identity. So this is called a Pythagorean identity. Okay? All right, so this is like the most famous trig identity out there. Okay? So now, suppose you take this one that we just found. All right? And just for fun, I'm going to divide each term here by cosine squared theta. Can we do that? Of course we can, because it's fun. So divide by cosine squared theta, divide by cosine squared theta, divide by cosine squared theta. Okay? Okay, so take a look. What do we have here? Sine squared over cosine squared, right? What's sine over cosine? Tangent. Sine squared over cosine squared is tangent squared. Okay? So here I have tangent squared theta plus what's cosine squared over cosine squared? 1 equals, now I have, what's 1 over cosine? Secant. And 1 over cosine squared is secant squared. So take a look. Now, this is version 2 of that one. Okay? This is like version 2. Okay, so now I'm going to take that highlighted one again. And you know how it was so much fun dividing everything by cosine squared? Okay, so now I'm going to divide by sine squared, just so Bella isn't offended here.
No, I'm not,
I know. Well, I just chose that one first.
So it doesn't matter?
No.
Oh, okay.
So now I'm going to do sine squared first. I'm going to divide everything by sine squared. First term, what does that give me? Sine squared over sine squared? 1. Plus, what's cosine over sine? Cotangent squared equal to cosecant squared theta. And that is the third very famous identity. And now, take a look here. Sine squared plus cosine squared equals 1. The next one is tangent squared plus 1 equals secant squared, which we already found by dividing by cosine. And then we already found the third one by dividing everything by sine. So do you see how this is the main identity, and then the other two are just derived from the first one? Right. Okay? So these three together are the Pythagorean identities. Okay? Right. So now we're given this problem, and we're going to try to solve it. So each time, right, each time when you're given a problem to solve, you have to know that you should, you're able to use any of the identities that have been given to you from the beginning of the chapter. So far, we were given this, and we were given this. So from now on, anything that we are going to solve can use any one of the ones that I just bracketed. Okay? So let's take a look at this one. So cosine of theta is 1 over 3. Okay? And it says tangent is less than 0. Find sine and tangent. Okay, so we're given two pieces of information here. We're given this one, and we're given this one. Okay? So, we're going to be, you're always going to be given two of these pieces of information. Okay? The first one is going to have some numerical content. The next one is there for you to be able to figure out what quadrant your answers are going to be in. Okay? So we're going to use the information to determine the quadrant. Okay? All right, so let's see. Here's the unit circle. What are we told in information number 1, in the blue one here? We're told that cosine is 1 over 3, but more importantly, we're told that cosine is positive, right? So we are told cosine is positive. All right, where are the quadrants where cosine is positive? Is cosine positive? Cosine is positive on the first and last, fourth. Okay, we're also told, what are we told about tangent? Which means negative. Where is tangent negative? Second and last. The quadrant where two of them match is where your answers are. Okay? So answers are in this quadrant. Okay? All right, so that's the first thing you do, is determine the quadrant. Once you've determined the quadrant, you have to now search for a trig identity that most closely relates the quantities you have and the quantities you need to find. So in this case, I have cosine. I need sine, tangent. Okay? So which ones relate cosine to one of the other two. Sam, any ideas? Oh, yeah, go ahead.
So will the answer always be in the quadrant that has the positive and the negative answer?
Yeah, it's the one where there are two of them, whether it's positive, positive, or negative, negative. Okay, so which one of these identities here, either here or here, relate cosine to one of the other ones? First one, right? So we're going to use this one. Sine squared theta plus cosine squared theta equals 1.
What is going on?
Okay? All right. So, can we plug stuff in here? Okay. Are we given sine? No, that's what we need to find. Are we given cosine? It's 1 over 3, but this is going to be 1 over 3 squared equals 1. Okay? So let's see what we get. Sine squared theta plus 1 over 9 is equal to 1. All right, now we're going to subtract 1 over 9. So sine squared theta is what over what? So, okay. So remember what we were doing? You multiply this way, and then you add that way. 8 over 9. We need to find sine of theta, so I take a square root of both sides. So sine of theta is plus or minus root 8 over 9. So root 8 over root 9. Okay? So sine of theta is plus or minus, what's root 8? Can we simplify root 8? 2 root 2 over 3. Okay? And now, which quadrant was this supposed to be in? The last one. In the last one, is sine positive or negative? Negative. So we say in quadrant 4, sine is negative. That means, you know how we said plus or minus 2 root 2 over 3? It's going to be negative 2 root 2 over 3. So sine of theta is negative 2 root 2 over 3. Okay, awesome. We just found sine of theta. What else do we need to find? Tangent. So let's see how we're going to find tangent of theta. Okay, what do we have so far? We have sine and cosine. Well, what's tangent? Yeah. Tangent is sine theta over cosine theta. So tangent is sine theta negative 2 root 2 over 3 over cosine theta 1 over 3. What happens here? You guys know this. The 3's cancel out. Negative 2 root 2. Okay, so congratulations, you've just solved your very first trig identities. I know. It's definitely something to be proud about. Okay? All right, let's do one more. Ay, is right. Okay. So next, we're given cotangent is 2. Yeah. Oh, it's just tangent of theta. So we're given cotangent is 2, cosine is negative. So first let's figure out which quadrant we're in. Here. Cotangent is 2. Where is, okay, so cotangent is positive, right? Where is cotangent positive? First and the fourth. No, first and the last. It's cotangent, it's like tangent. First and third. Where is cosine negative? and third. So our answer is in quadrant 3. Okay, now I have cotangent. I need sine and cosine. So are there any identities that relate cotangent to sine or cosine? So this one relates cotangent to cosecant, and cosecant is what? It's just 1 over sine, so we're going to use that one. So cotangent squared theta plus 1 is equal to cosecant squared theta. Okay? No, I'll give you these. All right, so what do we put here? Cotangent squared, what are we going to put in? 2 squared plus 1 equals cosecant squared theta. That's a 5. Okay, so how do we find cosecant? Take a square root. So plus or minus root 5 is cosecant of theta. What quadrant are we in? The third. Is cosecant positive or negative in the third quadrant? It's like sine. It's negative. So cosecant of theta is negative root 5. So now, what's sine of theta then? How are sine and cosecant related? 1 over. So it's negative 1 over root 5. And you can just leave it that way. Okay? Well, but we've only found sine so far. We also need cosine. So now take a look at what I have. I have cotangent and sine. Can I use those two to find cosine?
Yeah.
Which one? Yeah, or the cotangent one. Like I could use this one, right? So cotangent theta is cosine over sine. So this is, what do we need here? We need cosine. Let's multiply everything by sine. So cosine of theta is sine of theta, which is negative 1 over root 5, times cotangent, which is 2. So cosine of theta is negative 2 over root 5. Well, you know how here we had found that cosecant is negative root 5? But we actually needed the sine. So if you have cosecant and you want the sine, you just flip it over, 1 over. Okay?
Oh, negative 2 over 5.
Yeah.